Pluto, a far-off and baffling celestial body, was once an important part of our planetary system's family. However, recent disturbing proclamations from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have pushed Pluto back into public consideration. They have made a frightening discovery. Pluto may be on a potential crash course with Neptune. But how could such an event occur, and what might the consequences be? Is this a rare cosmic anomaly, or is there more to this impending celestial influence? Join us as we explore the possibilities of a potential Pluto-Neptune impact. Pluto, once classified as a planet but later redefined as a dwarf planet due to its unique orbit, continues to captivate the scientific community. According to recent research by leading scientists, Pluto's trajectory is dangerously close to Neptune's orbit. Notable astrophysicists like Tyson and Kaku are raising alarms about the potential for a catastrophic collision between these two celestial bodies, a scenario that could pose a significant threat to Earth. But how could such an event happen? Unlike any other planet in our solar system, Pluto's journey around the Sun is highly unusual. It takes a remarkable 248 years to complete just one orbit. Since its discovery in 1930, Pluto has yet to complete even a single full revolution, adding to its mystique. Yet Pluto's orbit isn't just slow, it's also highly elliptical, vastly different from the more circular orbits of the larger planets. To complicate things further, Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system. This inclination makes its path far more extreme than that of other planets, adding layers of complexity to its movement. One of the most intriguing aspects of Pluto's orbit is its interaction with Neptune's orbit. For approximately 20 years of each orbit, Pluto moves closer to the Sun than Neptune does, defying what we might expect based on the general positions of planets in our solar system. This naturally raises the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other celestial bodies, particularly the giant planets. The study of Pluto's orbit began soon after its discovery. Early astronomers were puzzled by its strange trajectory. Unlike other planets, whose orbits are somewhat aligned with the ecliptic plane, Pluto stood out due to its steep inclination and eccentric nature. The realization that Pluto's orbit crosses Neptune's was a significant point of scientific interest. Despite these peculiarities, the stability of Pluto's orbit is a remarkable feature of space mechanics. The phenomenon known as the three-body problem comes into play when studying the movements of Pluto, Neptune, and the Sun. This problem involves understanding how three celestial objects move and influence each other through gravitational forces. Predicting their paths is an incredibly complex task, and this is where terms like libration, scope libration, and VZK wobbling become significant. The concept of libration refers to the fact that when Pluto crosses Neptune's orbit, it remains at least 90 degrees away from Neptune, ensuring that their paths never intersect. Scope libration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it gets closest to Neptune, or any other massive planet, it is positioned above the plane of their orbits, offering additional protection from potential collisions. Another crucial factor is VZK wobbling, named after the researchers who studied how space objects interact through gravitational forces. This phenomenon explains how the gravitational pulls of Pluto, Neptune, and the Sun influence each other, keeping Pluto's path stable despite its seemingly erratic behavior. Although Pluto's orbit may appear unpredictable, this wobbling mechanism maintains its steady motion over long time scales. These complex forces help ensure Pluto's orbit remains stable, preventing it from crashing into Neptune or veering wildly off course. The three-body problem is essential for understanding how orbits change due to the gravitational influence of multiple objects. Studying this helps us gain a deeper understanding of Pluto, our solar system, and even distant celestial bodies and their stars. Numerical simulations conducted in the late 1980s revealed that although Pluto's orbit has stabilizing factors, it is still chaotic. Small changes in its initial conditions could lead to significant variations over thousands of years. However, despite this inherent chaos, Pluto's orbit remains stable over extraordinarily long time scales, effectively keeping any potential disruption in check. Recent computer models have provided new insights into how the gravitational influences of giant planets like Neptune, Jupiter, and Saturn affect Pluto's orbit. These models show that Pluto's relationship with Neptune is unique. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This resonance helps stabilize Pluto's orbit. But Neptune isn't the only force at work. Jupiter's gravity plays a critical role, as does Saturn's, providing additional stability. These simulations demonstrate that Jupiter's gravitational pull alone is strong enough to ensure Pluto remains in a stable orbit for billions of years. Together, Neptune, Jupiter, and Saturn work in tandem to keep Pluto safely on its course, avoiding catastrophic collisions or other disturbances. These gravitational forces are essential for maintaining order in the solar system. Without them, the system would be far more chaotic, with planets and dwarf planets like Pluto potentially colliding or being ejected from their orbits. Understanding Pluto's orbit is crucial to gaining a clearer picture of our solar system's dynamic nature. Pluto's case serves as a great example of how even the most seemingly unstable orbits can achieve stability through the intricate interplay of gravitational forces. It also highlights the importance of continuous observation and research to better understand our place in the universe. The study of Pluto and its orbit illustrates the unpredictable nature of celestial mechanics. The concept of orbital chaos, which refers to the extreme sensitivity of a body's orbit to its initial conditions, is clearly evident in Pluto's case. Even the smallest change in Pluto's position or velocity could significantly alter its orbit over time. Simulations have played a crucial role in helping researchers understand Pluto's motion. These computer models use complex mathematics to simulate how Pluto and other celestial bodies interact gravitationally. By adjusting small variables, astronomers can see how tiny changes can drastically alter Pluto's long-term orbit. In the late 1980s, these simulations revealed something fascinating about Pluto's orbit. While it may be stabilized by factors like libration, it can still be highly sensitive. Even slight differences in Pluto's initial position or velocity can lead to dramatic changes in its orbit over long periods. Despite this apparent chaos, Pluto's orbit remains relatively stable, persisting for billions of years. This suggests that while its path may seem chaotic, there is an underlying order to it. Predicting celestial events, especially those involving chaotic orbits like Pluto's, is a formidable challenge. The uncertain nature of Pluto's trajectory highlights the delicate balance that governs planetary orbits. While Pluto's current path is stable, even slight perturbations in the gravitational influence of neighboring celestial bodies could eventually alter its course. This raises questions about the long-term evolution of our solar system and whether Pluto's position will remain secure in the distant future. One of the primary concerns among astrophysicists is the cumulative effect of gravitational disturbances over vast time scales. Even minor external influences, such as the gravitational pull from passing stars, rogue planets, or even an undetected massive object in the outer reaches of the solar system, could introduce deviations in Pluto's orbit. While these changes would take millions or even billions of years to manifest, they highlight the fragility of orbital stability. Additionally, the study of Pluto's orbit ties into a broader discussion about planetary migration, the process by which planets and other celestial bodies shift positions over time due to gravitational interactions. Historical models of the early solar system suggest that Neptune itself migrated outward, influencing the Kuiper Belt and possibly displacing objects like Pluto. Could similar forces act on Pluto again, altering its future trajectory? Another factor to consider is the effect of resonances and perturbations. Pluto and Neptune are currently in a stable 3:2 mean motion resonance, meaning that for every 3 orbits Pluto completes, Neptune completes 2. This resonance acts as a protective mechanism, preventing the two bodies from colliding. However, planetary resonances are not necessarily permanent. Over immense time spans, they can weaken or shift due to additional gravitational influences, leading to unpredictable orbital changes. Could Pluto ever pose a threat to Earth? While discussions about Pluto's potential collision with Neptune are fascinating, some scientists are also exploring whether Pluto, or objects within its gravitational influence, could ever pose a risk to Earth. Pluto resides in the Kuiper Belt, a vast region filled with icy bodies, comets, and dwarf planets. If a gravitational disturbance were to significantly alter Pluto's orbit, it could also send smaller Kuiper Belt objects on a trajectory toward the inner solar system. Throughout history, cometary impacts have played a significant role in shaping Earth's geological and biological history. Some researchers speculate that gravitational disturbances from massive planets like Neptune and Jupiter periodically send Kuiper Belt objects hurtling toward the inner solar system, increasing the likelihood of impact events. Could Pluto, through a shift in its orbit, contribute to such a scenario? Although Pluto itself is unlikely to be perturbed in a way that would send it toward Earth, the same cannot be said for its surrounding environment. The Kuiper belt contains countless smaller celestial bodies, and if Neptune's gravitational influence were to shift significantly, perhaps due to an external factor like a passing rogue planet or an undetected massive object in the outer solar system, it could destabilize Pluto's orbit. In turn, this could displace numerous Kuiper belt objects, sending them toward the inner planets, including Earth. The possibility of such an event remains highly speculative, but it highlights the delicate balance that governs celestial mechanics. The solar system is an intricate web of gravitational interactions, and even small disturbances can lead to dramatic long-term consequences. The future of Pluto's orbit. One of the greatest challenges in astrophysics is predicting the long-term stability of planetary orbits. While current models suggest that Pluto's orbit will remain stable for billions of years, they also acknowledge the inherent unpredictability of chaotic systems. The long-term evolution of the solar system remains an open question, as even tiny perturbations from interstellar forces could influence planetary orbits over vast timescales. Some scientists are also investigating whether Pluto could eventually be ejected from the solar system altogether. If an exceptionally strong gravitational disturbance were to occur, such as an interaction with a rogue planet or a distant star passing near the solar system, it could theoretically alter Pluto's trajectory to the point where it is flung into interstellar space. Such events are rare but not impossible. Meanwhile, continued observations and simulations will help refine our understanding of Pluto's orbit and its interactions with other celestial bodies. Future space missions to the outer solar system, such as those exploring the Kuiper belt, could provide new insights into the long-term behavior of Pluto and its surroundings. Conclusion. Pluto's orbit is a marvel of celestial mechanics, demonstrating how even seemingly chaotic paths can achieve long-term stability through gravitational interactions. While concerns about a Pluto-Neptune collision have been largely put to rest by astrophysical models, the study of Pluto's motion continues to provide valuable insights into the dynamics of our solar system. As we continue to explore the cosmos, Pluto serves as a reminder that even the smallest celestial bodies can play a crucial role in the grand mechanics of the universe. Whether through its complex orbit, its relationship with Neptune, or its place in the Kuiper belt, Pluto remains a fascinating object of study, one that challenges our understanding of planetary science and the forces that shape our cosmic neighborhood.